Okay, so in this video, we're going to go over the review for the 7.4, our second to last quiz for the year. So you want to excel in this so that you can possibly be exempt from the final, or at minimum, be ready for the final and be a successful pre-calculus senior. Okay, looking at the first problem, notice that we're looking for angles. And the angles are going to be less than 2 pi and greater than or equal to 0. So that means unit circle angles. So you want to be able to work with the unit circle. You want to have it in front of you. I'm going to give it to you for the quiz. Basically, you want to know the following. So you want to know all students take calculus. And then I'm going to just put a couple of values here in the first quadrant for you. You do not have to memorize this. You will have access to the unit circle, but I'm just going to put this here so that I can refer to it as we go. So that's 1. Let me get rid of my little all here. And what angle is this one? This is pi over 6. This is going to be pi over 4. Which is going to be radical 2 over 2, comma, radical 2 over 2. And let me just slide down a little bit. And this is going to be pi over 3, and that's going to be 1/2 radical 3 over 2. Okay, what else should you know? You should know that your x and y are cosine of the angle and sine of the angle. You should know that tan is sine theta over cosine theta, and cotan is cosine theta over sine theta. Okay? All right, so let's get going. Okay, this is simple algebra. So what you're going to do is you're going to isolate your trig function on the left, the number on the right. So 2 sine theta equals 13 moved over, so negative 13 from 12 gives you a negative 1. Okay, so then I want to isolate my trig function. Never separate the theta from the trig function. Okay, so this is what you have, negative 1/2. So what you want to know is that sine is negative in 2 quadrants. All students take calculus. Sine is negative here and here. Figure out when the sine is 1/2 and sine is 1/2 at the pi over 6 angle. Okay, so look right here. That's where sine is 1/2 at pi over 6. So down here, we're going to use the pi over 6 angles to match up the denominator in the 3rd quadrant and in the 4th quadrant, and that's all there is to it. That's your answer, and you are done. Okay, going over to number 2. Same idea. Move your trig function to the left. So I'm going to subtract 3 tan theta from both sides. That's going to give me just 1 tan theta, or tan theta. I'm going to write it carefully like this. Then I'm going to subtract 6. Subtract 6. I'm getting tan theta equals negative 1. Okay, so tan theta, first off, tan is negative 2 places. Here and here. And for tan to be 1, sine and cosine have to equal each other. That only happens at pi over 4. So take that 4 of the denominator and match it up with 3 pi 4 in this quadrant and 7 pi 4 in this quadrant, and then you are done. Okay, moving on to problem 3. And remember, you can stop the video at any point. Don't be so concerned with copying everything down and getting those 4 points for homework. You have to be concerned with understanding the approach so that you can be successful on the assessment. Okay? Okay, so I have 9 cotan theta plus 7 equals 8 cotan theta plus 7. Okay, I'm going to move my 8 cotan theta over. I subtract it. That leaves me with 1 cotan theta. I'm going to move my 7s over. That's going to cancel both of them, and that's a 0. That's totally fine. Okay, so think about cotan being 0. So this is what I would have you think. Think about 0 as being 0 over 1. Cotan is cosine theta over sine theta. You need cosine to be 0. Okay, where does that happen? Look at your unit circle. Those are quadrantal angles that are going to be in play. And look at pi over 2, and look at 3 pi over 2, and you should see that the value there is 0, 1, and the value at 3 pi over 2 is 0, -1. Whether you divide by 1 or by -1, that sine value will still help you make the cotan equal to 0. Okay? Moving to number 4. Okay, so I'm going to get everything on the right that are numbers, that are just standalone numbers like this -3. So I'm going to say 9 secant theta equals, when I subtract 3, I get 18. Now I'm going to undo the multiplication. Undo the multiplication. I am getting secant theta equals 2. Okay, now, remember, secant is a reciprocal function. It's the reciprocal of cosine. So if secant equals 2, then that means cosine has to equal the reciprocal. Flip that over, because 2 is just 2 over 1. Okay, there are 2 places where cosine is positive. All students take calculus. Everything's positive here, so cosine certainly is positive there. And only cosine and secant are positive in the 4th quadrant. Okay, so come back up to our unit circle. Where is cosine equal to 1/2? And it looks like it's the pi over 3 angles. So pi over 3 in this case is an answer, and then so is 5 pi over 3. Notice the denominators will always match. You would never get a pi over 3 and then something over 6 in the other quadrant. That would never, ever happen. Okay? Okay, keep going. Oh, now I have squared. So a squared function, I'm going to be on the lookout and make sure I handle this correctly. So start the same way. Move the 1 over, 1 over. I'm getting 4 secant squared theta equals 16. Divide by 4, divide by 4. So that's going to give me secant squared theta equals 4. Okay, now, I don't want secant squared theta. I want just to have secant theta. So I'm going to take the square root of both sides. Okay, when you take the square root of secant squared theta, you get plain old secant theta. But when you take the square root of 4, when you have a square root situation, you're going to get plus and minus every single time. Okay, that is a mistake waiting to happen. Don't make it. Okay, if secant theta is plus and minus 2, then that means that cosine theta is still plus and minus, but take the reciprocal, which is 1/2. Okay, that's going to give you, I'm going to look back up again at my unit circle. You're going to have all 4 quadrants, but cosine is equal to 1/2 when you're at the pi over 3 angle. So you're going to have all of the pi over 3 angles. Here's a positive for cosine. Here is a negative for cosine. No problem, because I have to have negative answers as well. Here's another negative for cosine. And here's the other positive for cosine. So notice all the denominators are 3, and you have 4 answers when you have a square root. Now, a word of caution, or just a word of understanding. When doing these factoring type things with trig functions, you can get anywhere from 0 to 4 answers. Okay, so just be aware of that. Okay, next one. I'm going to deal with tan now. It's tan squared, but I have a method. Add 3 to both sides. That gives me 9 tan squared theta equals what? 27. Divide both sides by 9. you get tan squared theta equals 3. Okay, take your square root of both sides, because we don't want to have a squared trig term. And by the way, you never square the angles, you square the trig terms. That's why it looks the way it does. Okay? All right, so when I square root, I'm going to get plain old tan, and then the second I take the square root of the number, I'm going to do plus and minus. Okay, so plus and minus radical 3. Okay, interesting. What's happening here is I have to go back up and I have to figure out, okay, I know that tan is sine over cosine. So the sine must have a radical 3 in the numerator, and the cosine must have a 1 in the numerator. Okay, because those denominators of 2 will cancel out when you do division with fractions. So just bear that in mind. So come back up to my unit circle. Where do I see sine at radical 3? Well, I see that at the pi over 3 angle. So the pi over 3 angle has a sine value of what? Root 3 over 2. And this has a cosine value of 1/2. So if you say radical 3 over 2 divided by 1/2, remember that's equivalent to saying 2 over 1, aren't you really evaluating numerator over numerator? Because your end result are the numerators. The denominators that are 2 fall out. Okay, so now I know that I need all of the, all of the pi over 3 angles. So I need 4 of them because I'm doing plus and minus. There's 2 places where tan is positive, 2 places where it's negative. That is exactly why I am getting 4 angles for my answers. Okay, there you have it. Okay, let's keep going. So next one, I'm square it again, but you should be able to not stress about this. Just enjoy this process. So I have 4 sine squared theta equals 1. Sine squared theta equals 1/4. Okay, I'm going to take the square root of both sides. This becomes sine theta. This becomes plus and minus radical 1, which is just 1, over radical 4. Now, radical 4 is a perfect square. So this is becoming plus and minus 1 over 2. Okay, so where is sine 1/2? Sine is 1/2 at the pi over 6 angles. And again, you have to be using a unit circle when you do this. There are several that I've given you, plus I believe the first day of notes for 7-4. I attached it to the notes, so therefore it should be on the Google Classroom for that first date as well. So you want to be using a unit circle. Don't just go by my thoughts, because then you're not going to really be confident when you are looking for your angles. So use your unit circle. 7 pi over 6. And remember, you don't want to have it filled in all the way around. You want to be using reference angles, so you only have the first quadrant filled in. Okay, that one's done. Moving on to the next one. Subtract 7 from both sides, you get 6. So that's cosine squared theta equals 6 over 8. I'm going to reduce that first. That's going to be 3 over 4. Now take the square root of both sides. That's going to give me cosine theta equals, take the square root of the numerator over the square root of the denominator. Okay, remember that radical 4 is a perfect square, which is 2. And don't forget, the second you take that square root and you clean things up, it has to be a plus and minus every single time. So where is cosine radical 3 over 2? Let's see. There it is. First angle, pi over 6. So you need how many angles? You should be saying 4. So this is pi over 6. And then we need all the other ones. So 5 pi over 6, 7 pi over 6, 11 pi over 6. Done. Okay, let's go to the next one. Cotan squared theta equals 3. Okay, so we're set to take the square root right away. So the square root of cotan squared theta equals the square root of 3. And don't forget, the second that you're taking the square root, it's going to be plus and minus radical 3. Now, let's think about this. Remember, this is radical 3 kind of over 1. And cotan is cosine over sine. Therefore, where is cosine radical 3 over 2? Where is that? That's the pi over 6 angle. So guess what we're going to have? We're going to have the exact same answers that we had for number 8. So I'm just going to circle these and say copy, and I'm going to paste them right here. Okay? So there you have it. Okay, now we have some more factoring. The first one, number 10, is the difference of perfect squares. Oh, and I should go back and tell you one thing. Okay, this one should have been 7 because the other one was 6. So just make a note of that. Okay, this is the difference of perfect squares. So this is just cotan theta minus tan theta. Remember how you factor the difference of perfect squares? Cotan theta plus tan theta. You have two factors. Set each factor to 0. Cotan theta equals tan theta. And then the other one is cotan theta equals negative tan theta. Okay, you have to think about this. When is cotan and tan the same value? That's going to be where they are both 1. Okay, those are the pi over 4 angles. Now, because cotan and tan are reciprocal, they will always, forever and ever and ever and ever, have the exact same sign. They'll both be positive here. They will both be negative here. They're both positive here. And they're both negative here. Those are your answers. Never, ever, ever, if they're reciprocal functions, could they have different signs. So there's no answer from that factor. Okay? So think about that. Figure out what your tan and cotan are going to be at those 4 angles I have identified. You will notice that when you flip it over, it's going to have the exact same value. 1 over 1, when you flip it, it's still 1 over 1. They will never have different signs because they are reciprocal functions. Okay, so that's just a thought process. Let's go on to number 11. Okay, so this is what I would term easy factoring. It's easy factoring because the leading coefficient, which is sine squared theta, has a coefficient of 1. So bring everything to the left side and set this equal to 0. Minus 5 sine theta minus 6 equals 0. Okay, we're going to do some substituting. Now, we're just going to make this visually easier to deal with. And I kind of like the idea of doing substitution because so those of you that go on to study calculus are going to learn about things like mu substitution. So this is my substitution. I'm going to say sine theta is x. Okay? That means that this problem becomes x squared minus 5x minus 6 equals 0. So I say to myself, what multiplies to negative 6 and adds to negative 5? And that's going to be a negative 6 and a positive 1. So my two factors are x minus 6, x plus 1. Okay, multiply these two together. Make sure that you are getting the minus 6. Then you can FOIL it and make sure you get the minus 5. So you are set, and you've done this correctly. It's easy, easy, easy to make a mistake. Okay, set your two factors equal to 0. That gives me x equals 6 and x equals negative 1. At this point, undo your substitution. And you're going to say sine theta equals 6, sine theta equals 1. Okay, there are no angles that have sine values of 6. If you look at your unit circle, sine will never go above a 1. It'll never go below a negative 1. So therefore, its range is that. You cannot have 6s. No angle is possible. Okay, where is sine theta equal to 1? So think about that. Look at the unit circle. Sine theta is equal to 1 down here at the angle 3 pi over 2 because the coordinate pair. Okay, hold on a second. I'm so sorry. This should be negative 1. Negative 1, negative 1. The coordinate pair down there is going to be what? 0, comma, negative 1. And that's how I got that answer of 3 pi over 2. So here, the only angle that I can get is the 3 pi over 2 because where sine theta equals 6, there are no angles that have that value. Okay? All right, let's keep going. Okay, so here we're going to move everything to the left. 6 cosine squared theta minus 9 cosine theta plus 3. Make sure you change your signs correctly because that's an easy mistake to make. Okay, this is what I would deem hard factoring, and I'll show you why. Okay, so we're going to do the conversion. I'm going to say cosine theta equals x. Okay, so I get 6x squared minus 9x plus 3 equals 0. So I say to myself, what multiplies to 3 times 6, which is positive 18, and adds to negative 9. So I'm writing out my thought process here. So if you're weak in factoring, you've got to commit these procedures to memory. Okay, so what two numbers do that? Multiply to 18 and add to negative 9. Okay, so I think it's going to be a negative 6 and a negative 3. So this is decomposition. The middle term gets decomposed into the two values we have just identified. Now, when you decompose, you can't create anything new. So look at your negative 6x and your negative 3x. You should see that when you add those, you get negative 9x. You've just changed the way it looks. Okay, this is how I do hard factoring successfully. Underline the first pair. Skip the operation. Underline the second pair. Look at the first pair only. Factor out what they have in common, 6x. How can I get that expression back? Multiply by x minus 1. When you distribute, you should see you get 6x squared minus 6x. Bring down the operation. Match up the x minus 1. Give yourself a term here that makes the negative 3x plus 3 come back. Look at the 3. If I multiply negative 3x, I get negative 3x. And negative 3x times a negative 1 gives me positive 3. So bingo, I'm set. Okay, what are my factors? Look at the ones that are outside, including that sign that you pulled down. This is an important step right here. And here's the factors you already have. Okay, set these factors equal to 0. This is going to get you x equals 1/2 when you reduce, and x equals 1. At this point, you recognize that you really have cosine theta equals 1/2. Where does that happen? That happens at pi over 3 and at 5 pi over 3. And then you also have cosine theta equals 1. And where does that happen? That happens right over here at 0. Okay, so you have 3 angles for this problem number 12. Okay, that brings us to 13. So that And what I'm seeing is I have secant. I'm not going to panic. I'm just going to handle that the same way I've handled sine and cosine. It is a trinomial, so I'm going to do my factoring. This is going to be hard factoring again because the leading coefficient is a 4. Okay, so I'm going to switch over to my x's, right? I'm going to say my x this time equals secant theta. So this is going to be 4x squared minus 2x minus 2 equals 0. And I'm going to say to myself, what two numbers? So multiply what? Negative 2 times a 4, multiply to a negative 8, and then they have to add to a negative 2. So what two numbers will do that? Okay, 4 and 2 multiply to an 8. So it's going to be negative 4 and positive 2. And decomposition is our mission. Decompose this middle term. 4x squared minus 4x plus 2x minus 2 equals 0. Okay, that looks good. Underline your first pair. Give yourself a gap where that operation is. Underline your second pair. Look at your first pair. We have 4x, and then we have x minus 1. Bring down that operation. Make these match. Think about what number can go here to make everything work, and the number is 2. Your factors are 4x plus 2 and x minus 1. So your solutions are x equals what? Negative 1/2. X equals 1. Remember, we don't really have negative 1/2. We really have x. We really have secant theta equals negative 1/2, and secant theta equals 1. Remember, secant is the reciprocal of cosine, so therefore cosine theta equals negative 2 when you flip it over, and cosine theta still equals 1 because 1 is just 1 over 1, and when you flip it, it's the same. Okay, so we know, just like sine, cosine cannot be less than negative 1. Its range is also negative 1 to 1 inclusive. Now, tan does not have that range. Tan, you can have it be negative infinity to positive infinity. So don't worry about having values beyond the 1s or the negative 1s for tan. This just happens when you have cosine. So there's no angles available here, and it happens for sine as well. Where is cosine equal to 1 for number 13? Right here, what is that value? Cosine is 1, 0. The coordinate pair is a 1, 0 for the angle 0 radians. Okay, notice that we don't use 2 pi. How come? Because look what they're asking you to solve. They're going to ask you to have it be always less than 2 pi. So given that first angle, you're always going to pick the 0 radians for your answer. Okay? Okay, so I think I have, one more problem? Number 14 is it? Okay, so let's look at 14. That's a cosecant. Again, we are not going to flip out. We're just going to handle it just like we have handled everything else, with confidence and with a systematic approach. Okay, so again, I'm going to say, let's make our x equal to cosecant theta. And I'm going to rewrite this as 3x squared minus 3x minus 6 equals 0. Okay, this is also hard factoring in that the leading coefficient is greater than 1. So I say to myself, what multiplies to a negative 18, and it has to add to a negative 3. Okay, so what's that going to be? So I think I'm going to have a negative 6 and a positive 3. So let's decompose that middle term. 3x squared minus 6x plus 3x minus 6 Okay, I get negative 3x back, so I know I'm good. Underline the first pair, give yourself a gap where you have your operation. Factor out what they have in common, 3x. This is x minus 2. Bring down that operation. Make that factor match. Think about what goes here. It's going to be a 3. Get your two factors, 3x plus 3, x minus 2. Just make sure that they FOIL correctly because everything you do going forward is based on the correct factors. So this is going to get me x equals negative 1. Also do that step carefully. X equals 2. Now, I don't really have x. I actually have cosecant theta equals negative 1. And this is cosecant theta equals 2. Cosecant is the reciprocal of sine. So sine theta still equals negative 1. And this is going to be sine theta equals 1/2. Okay? So what angle has a sine value of negative 1? So I believe it's just going to be this one down here, which is 3 pi over 2. You get one angle there for that first factor. What has a value of 1/2 for sine? And is pi over 6. And also in the second quadrant, you're going to have, what, 5 pi over 6. 5 pi over 6. So you get 3 angles for this answer